Good morning.
Hello, good morning, good afternoon, good evening,
Hmm.
wherever you are.
Yep. Greetings from Redmond, Washington.
Excellent.
Yeah,
New York here.
We'll give people about another 5 minutes to trickle in.
Hi.
Yeah, Vishay. I just posted a link to the agenda. If anyone would like to look, add their name or indicate that they're present. Still going to give people 4 minutes or so. We usually start about 5 after the hour because people are coming in from other meetings. Good morning. Giving people a few more minutes.
Morning.
Morning. Josh, I just approved your pull request with the revisions. I don't have access to merge it, but I'll see if I can ping someone who does. Oh, obviously, do you have power to merge it? Okay, cool.
Yeah.
Ping you? Okay.
I just wanted to use today's call to ask if somebody else wants to review it and then merge it.
That makes sense. Cool. We'll do that in just a little bit. All right, we're gonna give people 1 more minute and then we'll go ahead and get started. And in the meantime, since Zoom does not show the chat history to people who've newly joined, there is a link to our agenda. Please go ahead and add your attendance. Take a look at the agenda today. I think this might be a short meeting, or shortish meeting, which is fine. A lot of people had conflicts today. I love seeing what animal. Oh, there's an anonymous rabbit. I love seeing what animals it chooses when people are looking at the doc for anonymous such and such. And for anyone who doesn't know, I have pet rabbits, so I was delighted to see an anonymous rabbit appear in the doc. All right, well, it is 5 after, so let's go ahead and get started. Welcome to the bi-weekly meeting of the Memory Safety SIG. And good to see all of you here. Is anyone here for their first or second meeting of this SIG?
Hi, this is my first time.
Oh, welcome. Would you like to introduce yourself?
Yeah, so I'm Suraj and I'm working for Freshworks as a security engineer. And I currently live in Delhi, India.
Cool. Awesome. Well, great to have you here. Must be kind of late for you.
Yeah,
Yeah,
was thinking the
it's
same.
almost 10:35.
Oh, wow. Well, thanks for staying up to be here with us.
Thanks.
Yes, and my name is David Edelson. I work at IBM Research. I'm also a member of the GNU Toolchain team, leadership GCC steering committee, and working with also bringing Rust to GCC and interested in all the fun stuff we're doing with memory safe languages.
Awesome. It's great to have you two here. And let's go ahead and dive into the agenda. So we welcome new friends. Would anyone be willing to take notes? As I mentioned in previous meetings, I just found I cannot take notes and speak at the same time. Can we have, oh, obviously, thank you. Yeah. Oh, looks like Jay is connecting to audio. Awesome. Cool. All right, let's quickly review some in-progress work. We have a couple of pull requests open, one of which I just approved, but I want to see if anyone else wants to, oh, that's not the thing I want to do. Anyone else wants to take a look at it? It's a smaller one from Josh, adding in some challenges to the doc we're writing, which is a rewrite of the language around the memory safety stream of the open source security mobilization plan. And this is mentioning the challenges with larger dependency chains, particularly since it's common to at least appear to have a larger dependency chain when software is written in Rust versus written in other languages.
Yeah, one note about that. We've been spending a lot of time looking at this problem, and I think the logistics of the large dependency chains are not such a problem. What we're really focusing on now is the web of trust that's involved there.
Mhm.
So how many people, how many different maintainers and sets of maintainers do you need to trust in such a large dependency chain, which is not something you can automate away with a nice package manager so easily. So we're really focused on the issue with the large number of dependencies is not whether you can manage that in the logistical sense, but how many people does that mean that you trust?
Yeah. Yeah, can you trust what's coming in? Obviously, you were muted for a moment there.
I'm typing.
Oh, okay. Oh, gotcha. Yeah, I think that sounds logical. And I know that is an area the OpenSSF as a larger org is looking at with things like SBOMs and other things. How do you have this very large web of trust, this ecosystem of trust, when you're using so many different components from so many different things? So it's good, I think, to call that out in our document. Does anyone else have any thoughts on this pull request or potentially some feedback?
I guess I'm confused about that first sentence of why it's inherently very different from C. I mean, it just
Josh, would you like to address that?
Sure, I'm trying to pull up the exact sentence here.
There's a link to the PR in the chat.
This is many memory safe languages have dependency models that are very different from C, often
Yeah.
resulting, I guess the previous should say in or with or larger
Yeah.
dependency chains. I think there's a preposition missing there. But I mean, the rest of it's,
Yeah,
I mean,
yeah, there
most
is
of
a
it
word missing. There is a word missing. It's often resulting in larger dependency chains. I can try to fix that after this call.
right. But I'm just curious. I mean, I'm not sure
Yes.
why that. I mean, what exactly that sentence? Well, I know it's trying what it literally says, but I'm not certain why it's sort of necessary or why it's trying to distinguish that.
Yeah, so if you look at dependency trees for, utilities included in operating systems today, they are not very big compared to dependency trees for roughly equivalent programs in Rust. So the Rust programs will typically have a much larger, more extensive dependency tree than the equivalent C program in an operating system. There are probably a few reasons for that, but one of the most important ones is that it is a real pain in the butt to add dependencies in C and then ship them across the ecosystem. Rust, for example, has the cargo package manager, and that makes it really easy to add dependencies. And because it's easy to add dependencies, people do add a lot more dependencies. They tend to add dependencies for things that are just smaller snippets of reusable code. Whereas in the C world, it would be a pain to add a dependency. So you just put that C code in your own source code or something like that. So I think the package manager system is what leads to these much bigger dependency trees. And they have pros and cons. I mean, the big con for me is the web of trust is much larger. There's just way more people that you're trusting in your average Rust program. The pro is the structure of programs is often more clear. There's less code duplication, things like that. But I think that's the heart of the matter. Is that cargo is similar. It's a similar deal with like Node and Go, where they also have npm, Python. They all have these package managers that just make it really easy to make dependencies, and that does not exist in the C world. So they just have fewer dependencies.
Okay, but I think of, I mean, like Mozilla and Chrome, I mean, have, C++ programs have huge numbers of dependencies. I mean, it depends on the application, and some of these efforts to rewrite like mod TLS and other things in Rust, I don't think that those inherently have more dependencies. So that's, I think it's sort of how you write.
So things like
I
mod
guess what it
TLS.
seems like, I'm not certain it's a characteristic of the language itself. That's, I guess, what I'm sort of, you could,
Sure, it's
not memory
characteristics of
safe
the
languages.
package
Like,
manager
I mean, modern
associated.
programming styles or other things have more dependent. And yes, it's good to give the motivation with dependency chains, but I'm not, I guess I just find it sort of that the motivation, the reasoning there doesn't fully make sense to me, or what you're ascribing the reasoning to doesn't fully make sense to me. It doesn't. We can leave it at it just doesn't. It seems sort of orthogonal to the rest of the document. It's like.
Go ahead, Josh.
Sorry.
If there's something I can do to make it more clear, I'm happy to do that. I do think that things like Firefox and Chrome are pretty big outliers in terms of how massive they are, and they're not really what I'm talking about. But if you look at things like even mod TLS, which you cited, right? Mod TLS itself doesn't necessarily have to have more dependencies, but because mod TLS uses Russell's, the Rust TLS library in the background, it does in fact have way more dependencies than the C equivalent, which uses just OpenSSL, which has far fewer dependencies for basically the reasons that I cited. And so leaving aside some of the outliers in the C++ world, which do have massive numbers of dependencies, when we have been rewriting things like NTP and sudo and some other things, the dependency trees are definitely on average much larger. So if there's something I can say that would help encapsulate that better, I'm happy to improve the paragraph.
Does anyone have any suggestions on that?
Yeah, I think this is a really interesting problem space, and I'm kind of curious how much it is just dependency chain depth and how much it's also to do with the way that servicing happens and static linking and the way that people manage these sets of dependencies in operating systems. I don't have, you know, deep insight into that space. It's kind of, I've more worked with people working on, you know, Linux distros and things. But there is definitely some cultural difference there in terms of what packages are, how they're statically linked, how you manage CVEs and service different layers of the stack. And so they're kind of like, they're different granularity in terms of, you know, you might think of a package as being a dilib and all the code, and then it might depend on some other dilibs. And that's how you might traditionally think of packages. Whereas when you think of crates, they're kind of components of that binary. And if you project those crates into being packages in your like, they don't look like what your packages look like before, both in terms of how you can service them independently and how they aggregate into other things. So I think there is like a sort of, I don't know whether you call it an impedance mismatch or whatever, between what traditional packages look like and what crates look like. And I don't know whether it's just the depth or the volume that's the biggest issue, or whether there's something else there. And then I guess coming back to the work of this group, this feels like a Rust specific adoption concern, but I don't know how much it has to do with the memory safety and how much it's more just like, this is how modern languages look in terms of how you componentize and how you have the boundaries between things versus the way that we use other languages. But I don't know whether that's inherently around the memory safety aspect. I don't know.
Go ahead,
I don't
Josh.
think that's very helpful, but
I think you're totally right that on top of this whole like size of a tree issue, there are all sorts of cultural and, you know, just cultural differences and ways of structuring things differently. The way that I mean, this is not intended to be specific to Rust. So when I talk to packagers for Ubuntu and Red Hat, this same conversation comes up for Go, for example, especially around Kubernetes components that are getting integrated into these operating systems. But I don't think it is specific to Go, but I do think that it is certainly an adoption issue as opposed to an issue of memory safety itself. For me, those two have become very intertwined. Like, I think we know how to write memory safe code, basically, and that's not really the challenge unless you're talking about assembly code optimizations for, you know, basically cryptography and video, you know, media codecs. I think those are the only two places where we don't really know how to write memory safe code in acceptable ways. So for me, this is really the next step in bringing memory safe to the ecosystem. Is not like, how do we write Rust or how do we write Go? The question is, how do we get that out into the wider world? And for me, this is the next frontier there, which is helping operating systems and everybody involved in this stuff understand what these different dependency chains mean. What do the cultural differences mean? How are these programs structured differently? And what does that mean for shipping them?
so is like, I guess is the problem that you present, hey, you should replace this package, sudo or whatever you have, with this Rust version. And now that means you have 50 or whatever different packages that you now need to maintain as part of your distro. Is it like just is it just that that's confronting and it's like a big, you know, it seems like a big undertaking to replace one package with something that's a lot more complicated? Are we worried about how the tools scale, or are we just worried about resistance from people wanting to own that many more packages and have to have people allocated to maintain and track them? Like,
your initial description of the problem is correct. And of the two things, I'm less concerned about the logistics and tools involved in packaging a Rust program with 200 dependencies. I'm more concerned about what it means to properly maintain those 200 dependencies and make sure that everybody involved in maintaining them is trustworthy. So when Fedora says, you know, okay, we have tools that can package 200 Rust crates into a program, that's fine. But now we're responsible for making sure that all of this stuff is secure. And that's that's a tough chunk of responsibility to swallow compared to the C equivalent that, in my experience, Rust equivalents tend to have 5 to 10 times the number of dependencies, and most of them are new. They're not something the operating system is already dealing with.
I guess that question is
Let's
where
go
I'm
to-
kind of interested
We'll do
is,
Daniel and then we'll go to David.
yeah, I guess the question of the newness for the first Rust program is obviously going to be, very significant. I guess one question I have is like, what is the incremental cost going to be over time if there's greater Rust adoption? Because I think the granularity is different, but there is a lot of code sharing. And so I don't know, like the first one might add 50 and the second one might add 30, and then, or are we seeing that there's a lot of very custom functionality and it's a pattern that for the 10th or the 20th Rust program, we would still see it? I don't know. Anyway, that's probably a bit of an open question.
Go ahead, David.
Well, no, I was agreeing with what Daniel said earlier, which is, and you seem to be saying that this isn't inherent to memory safe languages. This is part of more modern package-based, dependency-based building of modern languages. And those modern languages, many of them are more memory safe, but I'm not certain that it's really inherent to this. That's just where my concern about making this statement in this pull request, this document, that again, it's that this is something that's important, exactly as we were saying earlier with Josh, of how this is going to be a challenge, or how it's going to be made more complicated for the deployment of these replacement applications. But it doesn't seem that it's inherent. I mean, that it's a necessary characteristic. In other words, if one had Rust without the crate system and without the ease of, and crates aren't, it's a nice feature functionality in Rust, but the Rust language doesn't require crates. It's just a convenience. We could add a package system to C. So that's why I'm sort of saying that it seems like you're making a statement about the inherent design of memory safe languages as opposed to the inherent design of modern software development and software engineering.
So I like to summarize what I think I'm hearing. So what if we changed many memory safe languages to many modern languages, which tend to have better memory safety? So let's reflect that it's a modern language issue, not something that's inherent to memory safe languages. It's inherent to modern languages, which do
I don't. This isn't sort of fundamental to the, I think to this, document anyway. So I don't want to, just, bike shed this one sense, but it just, it was just curious to me that this is modern software engineering. Has this characteristic.
I think, like, on one hand, I very much agree that this is sort of seems tangential to some of the point of memory safe languages, but I think this is probably a good point to have a bit of a discussion of like what the role of this SIG is and what we're really seeking to achieve. And I think one of the ways that I see the mission here is that we are trying to like pave the road and understand what the blockers are, because say we have memory safe languages, we see they have value, but we want to connect that with actually having the adoption and moving that forward. And so the question then is, and Josh, I think, is speaking to a challenge that he has in terms of driving that adoption, where there's this cultural disconnect, and whether that's inherently to do with Rust versus any other modern language, it's still a kind of a cultural blocker for the Rust adoption or Go adoption in terms of getting memory safe languages to be used in these environments. And so I'm kind of very, like, whether it's part of this document or whatever else, but like it feels like it's in scope for us in terms of, is it part of our scope to try and drive that cultural push to be able to adopt these languages, or is it a place where we think the right thing is to push back in the other direction and use Rust without crates, which I think would be, I think that would make, be a big challenge in terms of we don't really have any of the code that's written there. So it would be starting from a pretty low base. So I don't know.
I think it's worth calling out in the doc, perhaps calling it out as a cultural challenge versus a technical challenge, because our SIG is within the developer best practices working group. Culture, as developer myself, getting developers to adopt best practices is a cultural thing. It's not just not just making technical arguments, changing the culture around it. I think it is worth calling it out as a challenge in moving critical internet software, moving software into modern languages, which tend to be memory safe.
I think it's good to think of it as a bit of a cultural challenge. I think it can also be a bit dangerous in terms of the mindset it pushes us into, like in that we know how to do things and we have to teach them how. And I'm not saying that you were suggesting that, but aside from the how to have a culture that can organize and manage and feel confident in terms of supporting all of these crates, which could have different sets of independent developers, sometimes only one or two, and all the, like you could task that as like a cultural challenge. It's more just like they've set up their organizations to be able to stand behind and feel confident in the security of the product they're building.
Mm-hmm.
We're trying to change some of the building blocks of that on them for a benefit that they might like, but it means that we need to have a way that they can work with, and there are other efforts out there like, blessed.rs, and I don't want to point too heavily at that, but there are efforts and other community efforts as well to try and identify trustworthiness in crates. And it's obviously an issue that we internally at Microsoft have a challenge around as well, right? So I don't want to diminish that challenge as just saying they have to, get with the program or whatever, which I know that's not what you're characterizing it as all. But yeah, so I'm just saying there's a risk of if we make it sound too much like a cultural thing, that it's like it's an organizational thing of how do they get to stand behind it, rather than a technical tooling limitation that we can write code to fix.
Right.
We may need to write some tooling to help support the organizational change, but it's like that I think is, I don't know, Josh, you can kind of chime in if that's not what you're angling at. Yeah,
I agree with you that, well, I'm not sure you're saying this, but I would say that calling it a cultural issue, I think, is not quite right. It implies that we know what like a better culture is, and I don't think that we do. Like at the end of the day, a lot of the sort of stuff that gets labeled as cultural behavior is just the obvious conclusion of the tools available, right? When you have a system like Cargo available in Rust, of course, people are going to behave the way that they do with regards to dependency chains, because that's what those tools encourage, and that's really central to the language. So that's not in my mind like an interesting cultural artifact here. I think we need to make some decisions, and I can probably start sharing some writing that I have with people where I sort of outline the problem long form, again focusing on this problem of large dependencies chains leading to trust issues. And in my mind, the solutions are in the bucket of we need to reduce the number of dependencies. One option, for example, is to include some more stuff in the Rust standard library. There are a lot of challenges around that, a lot of questions about what would you do, how would you best approach that. If you can't pull that off, the second best way to do it is basically stuff like blessed.rs. And if you can't do that, there are solutions down the line there. And I don't think that any of the solutions that I have come up with as plausible really involve cultural change. They involve making decisions about how dependencies are going to work going forward.
Understood. I do want to be cognizant of time. We do have some other stuff on the agenda. I'd encourage this discussion to continue. I think on Josh's open pull request is the best place for that to be. I think of course I won't merge it until you update it. Yeah, let's continue having the conversation there, so there's a record of it, and we will continue forward. Thank you for bringing those concerns up, everyone. Next item on the agenda is where we go. We have another open PR from Crow. I think, let me get a link to that. I think it needs just needs some markdown fixes. Let me just put a link to that in the chat. There we go. Right, so some words about proposing investments in education. We did have a discussion on standardizing on memory space safe or memory hyphen safe. We made some agreements last call on what to standardize on. And I think the PR just still needs a few edits. And I know Crow had a conflict today and has had some other stuff going on. Any other thoughts on that pull request? All right. And then once these two pull requests are concluded, I do plan to update the entire doc standardizing on memory hyphen safe or and the other things we mentioned in that pull request. I just don't want to cause horrendous merge conflicts for the existing pull requests. So I'm holding off on doing that until then. So that I think is our in progress work. And then David W. in absentia, I actually don't know how to say that word, proposed creating a page document with links to approaches to improvement in memory safety issues in languages where full memory safety isn't the default. I think this is a good idea. I personally think this should live in our GitHub repo, but I'm open to other suggestions as well. I don't hear any others, so I'm happy to add what is in the agenda regard links to that, create that in the GitHub repo, which I can take on as an action item. Abhishek, go ahead.
Nell, yeah, are we linked into the memory safety from the best practices? Because most of the best practices guide, like source control management, hardening, C++ hardening guides, those are found there. So I'm just thinking a user perspective, you know, I'm looking for my guides.
Within the best practices repo?
Yeah, usually.
That sounds logical. Yeah, I'd be open to that. Perhaps while we're compiling them, we have them in our repo, and then eventually, once we have a somewhat complete list, obviously it'll always have edits, and then we move it into the best practices repo. So we can iterate. I think we can iterate a little quicker when it's in our repo. All right. Well, that is the last item on the agenda for today's meeting. Was there anything else anyone wanted to discuss while we're together synchronously? All right. Well, hearing none, I very much am of the belief that it's okay if meetings end early if all discussion has completed. So thank you so much for those of you who've been with us here live. Thank you for those of you who are watching this later on YouTube. I do know that people watch it, and hello, good to see you. And thank you everyone, and have a wonderful rest of your week.
Thanks, great call.
All right, take care everyone.
Thanks. Bye.